Hey guys, this is Mr. Bennett, and this is Unit 6. We're talking about ions, acids, and bases, and this is video 6-1, so we're focusing on the ions. Alright, so ions we've talked about before. We know that ions are basically atoms that have gained or lost electrons, right? Well, it turns out that depending on whether you gain or lose, you have a special name. So a cation is an ion that has a positive charge. Now, it's going to be kind of tricky to remember which one's which. You might get confused. So my way of remembering what a cation is I remember cats, the cat part of the cation, cats have paws. So think of paws as being short for positive, okay? Or just think of it as like cats, meow, have paws, right? They claw at you. Anyways, so that's my trick for remembering cations are positive. Now, break it down. Cations are atoms that lose an electron, okay? Cations lose. Basically, by doing that, they become a cation and they have a positive charge. To lose an electron, here's what you gotta have. First of all, you gotta have a low ionization energy. Last unit we talked about ionization energy. This is the cost of losing an electron. Okay, so in other words, if the cost is too high, then you're not gonna lose an electron. It's gonna be too hard. But if your ionization energy is low, then the cost is really low, so it's easy or easier to lose an electron. Now, these guys also have low electronegativity. Electronegativity is the ability to attract electrons. So we already said that it's easy for them to lose electrons. It's also very hard for them to gain electrons. They have low electronegativity. So the odds work in their favor to lose electrons. They're not good at gaining them, and it's easy for them to lose them. And it turns out if we're looking for elements that have low ionization and low electronegativity, we're talking about metals. So metals are the cation formers. They're on the left-hand side, which means that the left-hand side, by left-hand side I mean left of the staircase, the left-hand side of the periodic table will be positive. Here's an example. We have sodium. Here's its orbital notation. Okay, it's got 2 in the 1s sublevel, 2 in the 2s sublevel, 6 in the 2p sublevel, and 1 electron in its valence, the third energy level. Okay, it's just got 1 there. And so the easiest way for it to get to its octet is to simply kick this electron out to get rid of it. Its valence is now the second energy level, and if we add this together, it has 2, 4, 6, 8 electrons in its valence, which is what we call an octet, right? And it turns out that this configuration is identical to its nearest noble gas, neon. So it's more stable, now has its octet, it's a happy little sodium. Now, if you go the other way, instead of losing electrons, if you gain an electron, that means you're an anion. Okay, they have negative charges. And the way I remember that anions are the negative ions is that I take this word and I break it up, and I think about it as A, N stands for negative, ion. So it's a negative ion. Okay, again, a little trick just for keeping them straight. Now, these guys are gaining electrons to become anions. To gain an electron, first of all, these guys have high ionization energy, which means they have a high cost for losing electrons. So in other words, they're not going to lose electrons because it costs too much. To take off an electron would cost an insane amount of energy, and so it's just not worth it. They have high electronegativity as well, which means that they're good at attracting electrons. So they're not going to lose electrons because it costs too much. They might as well just attract electrons because they're already good at that, right? They might as well gain electrons. And it turns out if you're looking for elements that have high ionization energy and high electronegativity, you're looking at the nonmetals. Okay, they're on the right side of the periodic table, meaning right side of the staircase, and these are going to be the elements that form negative ions, or anions. So to give you an example, here's chlorine. Chlorine has 7 valence electrons. They're in the third energy level. So in order to get to its 8, it's going to simply find an electron and take it. Okay, it's going to go right in there. And by doing so, its valence, meaning the third energy level, now has 2, 4, 6, 8. It gets its octet, which, I don't know why I put a C there, anyways, octet, which is identical to its nearest noble gas, argon. So it's got its octet, it's happy, right? It's stable.